completely unreasonable. All right. So let's talk about this thing right here, congruent figures. I got two things. Let's talk about this word congruent. You've seen that word before, right? We used it before. There's a symbol that goes with congruent. Do you remember what that symbol looks like? Looks like an equal sign with what? A little squiggle on top, okay? So that means congruent. I wasn't that picky in the past about using an equal sign compared to a congruent sign, okay? It didn't really bother me that much, but now it's going to, all right? This is where I think it's really, really important to write the congruent symbol and not just put an equal sign. Everybody got that? All right, so we're not saying that these things are equal to each other. What word are we using? Congruent, okay? We went through, like, in the last class, I think we talked about it maybe 4 or 5 times. People were still saying equal, and I got to tell them, we don't say equal, we say congruent. Then the next time somebody said equal, I'm like, we don't say equal. What do we say? Congruent. All right, so please don't make me do that. I know some of you are going to do it just to tick me off, but we're using the word congruent. So let's talk about congruent figures. So there's 2 things that must be true if things are congruent. Okay, and this is geometry class, obviously. So we are talking about geometric figures. Okay, you could be talking about anything. Like if I had 2 pens that were exactly the same. I got them in my pocket. All right, they're different colors, but that's okay. But these are exactly the same. Same shape, same size. Would you agree? All right, they're exactly the same. Like if in the dark, there's no way I'd be able to tell the difference between the 2 because they're exactly the same shape. They're exactly the same size. I can't tell the difference between them except when I look at them, I see one is black and one is red. All right, so congruent figures, they have those 2 things in common as well. They have the same, what did I say? Shape, and they have the same, what? Size. Okay? So anytime figures are congruent to each other, they have the same exact shape and the same exact size. Let me give you an example. So I let the last class pick their favorite, come on, there we go. Their favorite polygon. Anybody have a favorite polygon? A trapezoid. Yeah, that is a polygon, that's true. But as far as the number of sides are concerned, how many sides it has? I'll just use 6, okay? Okay, 4 would be okay. I could have used that too, but it's too late. All right, so here is a 6-sided figure. It doesn't matter how many sides we have. It doesn't matter that it's a perfect, we call this a regular polygon because all the sides and all the angles are equal to each other. I think we've talked about that. I think we have. Did we talk about a regular polygon? I don't know. I can't keep it straight between the honors class and this class, what I said when. But anyway, this is a shape. It's a geometric shape. Agreed? Now, if I do this, if I took this and I copied it, and then I did what to it? Copy and paste, right. If I pasted it, by the way, what is the keyboard shortcut for copy and paste? Control C for copy, and then Control V, right, Control V. Why is it not P? Why isn't it Control P? What's Control P used for almost all the time on a computer? You guys don't even use computers anymore, do you? It's so funny because it used to be I would teach before computers existed, and I was teaching kids didn't even know what a computer was. I didn't know what a computer was because we never used them, right? But then we went through a whole bunch of years where everybody was using computers, and now we're at a point where kids don't use computers anymore. They're just using their phones or an iPad or something. But anyway, it's Control C, Control V, all right, V, and it's not P because Control P is print, all right? Almost every program that you use, if you hit Control P, it's going to send you to print whatever your document is, all right? So it's V. Why is it V? That's a weird letter. Why V for paste? Because it's on a keyboard. Do you know your keyboard without looking? The C is right next to the V, all right? So V and C, that's why we use it. Okay, enough. There, you learned something besides geometry today. So I copied and pasted. So that means this has exactly the same shape and it has the same exact size. Or I could take this and then pick it up, and what would happen if I put it on top of the other one? It would match up perfectly and they would look exactly the same, wouldn't they? You with me on that? Okay? If I changed the size of it just a little bit, just a little bit, right? And I took it and I put it here. Do they match up perfectly? No, they don't, okay? So these would not be congruent, all right? Those would be congruent right there because they're the same size and the same shape, all right? Everybody got that? All right, what if I did this? And I tried to make it the same size. That's pretty much the same size, isn't it? Top and bottom, close. There we go. So it's kind of the same size, right? The top goes to the same place, the bottom goes to the same place. But are they congruent figures? No, because they don't have the same what? Shape. They have different shapes, okay? So they're not congruent to each other. So let's go back to this. So these are congruent figures. I could do that with any kind of figure, okay? It doesn't, I mean, it could be anything. I mean, it could be look, it could be something weird like this. That's a figure. That's a shape, isn't it? All right. So if I took this and copied it and pasted it, are they congruent figures? Yeah. What if I did this? What if I turned it? Did I change the size of it? Did I change the shape of it? No, I just changed the angle of it. Okay, that's fine. Like this same thing here. I could take this, move it around like that. Are they still congruent to each other? Yeah, they're still congruent to each other. Okay, so it doesn't matter how I twist it or turn it. Okay, as long as it has the same shape and the same size, then they're congruent to each other. All right, enough of that. Oh, by the way, let me say this before I move on to the next thing. Let's twist that back to where it was. So what if I said that this was equal to this, and this were equal, and so on. Boom, 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 boom. If that's what I knew, does that alone make them congruent to each other, just knowing that all the sides are the same? No, it doesn't mean it. It doesn't necessarily mean it. But they got to be both. Good, I like that. They got to be both. The same, this changes, or this shows that the size is the same. What do the angles show? That the what? That the shape is the same. That's right. So if all these angles, if this angle equals this one, and this one equals this one, and this one equals this one, and so on, okay, this determines its what? Its shape, all right? So if they all have, if the parts that line up with each other, right, if I pick one up, put it on top of the other one, if everything lines up, if all the sides are equal and all the angles are equal, then guess what's true about these two shapes? They are congruent to each other. Very good. Okay, everybody got me on that? All right. There's one more thing we're not going to do a whole lot of in this chapter. We have another chapter. I don't know if we'll ever get to it because it's later in the book. But we have a whole entire chapter just on circles. But this is the only time I think we're going to talk about a circle in this chapter. So I copied and pasted again. So guess what's true about both of these circles then? They're congruent to each other. Good. Okay, let's talk about a circle for just a minute. They have a point right in the middle. But we don't call it the middle when we name a circle. Any idea what we call this? Now the circumference is the distance around it. What's that point that's in the middle of it? It's the center of the circle, right? This is called the center of the circle. Now we also have, and this we've talked about this because we've done circumference, didn't we? Didn't we do the circumference of a circle? Yeah, 2 pi r, remember that? Or pi times d. All right, so watch. What is that little line right there called? That's called the radius of the circle. Come on, click off of there. Why isn't it? Did it click off? There we go. All right, so this is called the radius of the circle. How do I know that this circle is congruent to this circle? What do I look at? The radius. That's right. That's what I look at, okay? It doesn't have any sides. It doesn't have any angles, okay? But it does have a radius, all right? And that's what I look at. So if this radius is the same, so if this whoops, what's going on there? If this radius is 5, and if this radius was 5, tell me something about those two circles. They would be congruent to each other, okay? That's the only thing you have to know about circles to see if they're congruent or not. Because as soon as I start doing this, as soon as I make that circle a little smaller, what happens to that radius? It gets smaller, doesn't it? So are these congruent to each other? No, they're not, all right? So even if I put that in the middle, do you see that radius is bigger than the radius of this little circle? So how do I know if two circles are congruent to each other? They have the same radius, okay? Oh, you can't wait. Wait till I'm done. I'll be done in like 10 minutes. Can you wait? Yeah, I'll let you go too as soon as I finish this. Here's the last thing. We're going to do the last thing right now. Go ahead. What happens? It's only with a circle, right? Because these don't have a radius, okay? But they do have sides and angles. So when you have a figure, it could be anything. It could be a triangle, it could be a rectangle, it could be a square, right? It could be anything, a 100-sided figure. If all the sides that match up are equal to each other and all the angles that match up are equal to each other. Now, I keep saying match up. What's a better word for that? We've used it before. Starts with a C. Sum starts with C. Starts with a C. We've talked about this word before. Remember we had two parallel lines cut by transversal? The one up here, that does start with a C, but it's not the word. You had an angle up here was equal to angle down here, right? That top right one was equal to the bottom right one. No, not complementary. Corresponding. There we go. I knew somebody would get it. We only have so many words with C, but the corresponding. So everybody look. See this line segment right there? What's it corresponding to? This line segment right here. This is the top one. That's the top one. Everybody see that? Which one is corresponding to this one? The one down here on the bottom. You got it? What's corresponding to this angle right here? The angle over here on that right corner. You got it? So those are the ones that are corresponding to each other. So instead of saying which ones match up, that's an okay way to say it, but in geometry we use the word corresponding. So we're going to use that word here right now. So I'm going to do a triangle. We're kind of finished with everything that's not a triangle. From now on, pretty much, let me see. Yeah, pretty much from now on, we're just dealing with triangles, congruent triangles, okay? So let me write that down up here. So the rest of this lesson, this chapter really, the rest of this chapter is really about congruent, not just figures, but what? Oops, almost wrote figures. Triangles, okay? Congruent triangles. So this is the first time. The next lesson, the one after that, the one after that, the one after that, it's all going to deal with congruent triangles, all right? So this is the very first time we're really going to show you something about congruent triangles. And there's one thing that we're going to do here that's super important, all right? So I'm just going to draw some random triangle. I don't really care what it looks like as long as it's a triangle. I'm going to copy and I'm going to paste it. And oops. And there we go. All right, let's name this triangle. Let's call it ABC. And we'll just make this one easy and call it DEF. Okay? Now, here's what I'm going to show you. I'm going to show you a couple things here. Let's say that AB was equal to DE. Is that enough to say that they're congruent triangles? Just those two sides? No. But what if I said that this and this one are equal? Is that enough? Not yet. What about this one and this one? Well, not quite. With the information that we know, he's actually right. He's actually right, but we're going to learn this in another lesson. It's like 2 or 3 lessons from now. Okay, so he's actually right. But as far as we're concerned, these have the same lengths, but what else has to be true right now? Well, we already got the sides equal. What else has to be equal? The same shape. What determines the shape? The angles, that's right. So that means that angle A and angle D need to equal each other because they're corresponding to each other, right? If I took this triangle, picked it up, and put it right on top of this triangle right here, then the A and the D would match up. Everybody see that? What would the B match up with over here? What would it correspond to? The E. What would the C correspond to? The F. Okay, now, if right now, today, as we're standing, this is what I would have to know in order to show that these triangles were congruent. all the corresponding sides equal each other, and all the corresponding what? Angles equal each other. Would you agree with that? So that means if I took this, picked it up, put it right on top of this, they would be exactly the same. They would be, what's the word? Congruent. Good. With me? All right. Now, this is the key to what we're doing. That was fairly easy to understand. This is what's really, really important. This could be the reason of getting a problem right or getting a problem wrong, all right, when you do these things. And you're going to do a lot of these things through the rest of the chapter, so watch very carefully. This is just the beginning of it. So I could call this first triangle, I could call it several different things. What do you think is the easiest way to call this triangle? Triangle ABC, right. But I could call it what? Triangle BCA. Or I could call it triangle CAB or BAC or... I'm glad you're so excited about this. All right. I could call it any combination of A, B, and C. Would you agree? Okay. I'm just going to pick the easiest one. I'm just going to call it ABC. And since they're congruent to each other, how do I know they're congruent? Because all the sides are equal, all the angles are equal. Okay? All the corresponding sides and all the corresponding angles. Now, this is what's really super important right here. Okay? If I call this triangle ABC, now I could have called it a bunch of different things. I think there's 6 different ways I could have named that triangle. I decided ABC, all right? If I call this ABC, I have to call the other triangle a triangle that matches up with this. So my first letter was A, agreed? So which one over here matches up with the A? The D does, okay? The second letter was B. All right, so which one is corresponding to B? The E. So that has to go. It absolutely has to be in the middle if I call B, if B is in the middle. You follow me on that? What about C? C goes with F. So if I decided to call this triangle ABC, I must call this one triangle DEF. Right? Everybody see that? Okay, good question. It's exactly what I'm going to do. Would you say CAB? All right, let's do that then. Now, oh, by the way, we call this a, what did I call it? No, wait, hold on, give me a second. Oh man, I wrote it down in the last class. This is something I should know. It's congruence, oh my word. I can't believe I forget this word. I use this all the time when I teach this lesson. And congruence, oh, I don't know. It just slipped my mind. It's crazy. But anyway, I'll think of it. I'll write it down. Watch. If I call this angle CAB, I have to call the other one a certain thing. I can't just use any 3 of those letters in any order. If I go CAB, I have to do what? So if I call this C, what's the first one? What's the one that corresponds to C? The F. Okay. Which one corresponds to the A? The D. Which one corresponds to the B? The E. So I have to call it that. If I said, watch, if I wrote down triangle CAB, which is fine. I can call that CAB. It's perfectly fine. But I would have to call the other one FDE. What if I called it, whoops, let's put the triangle symbol. Always put the triangle symbol in front of the triangle when you're referring to it. Call it DEF, okay? Can I write this? No, because look, does the C and the D go together? They're, okay, you could not write this. Oh, it's a congruent statement. I just came up with it. We call it a congruence statement. See, it wasn't that hard. I just, for some reason, the older you get, the less things you remember, I tell you. So we call this a congruence statement, all right? So this would not be a correct congruent statement, all right? This is still triangle DEF, isn't it? This is still triangle CAB. But does the C and the D correspond to each other? No, they don't. I mean, then they should, right? If you're going to write it as a correct congruent statement. So this would not be a correct congruent statement. This would be okay. This would be okay. I could call this triangle a bunch of things, right? Let's do one more. What else could I call this triangle ABC? What is it? BCA. All right, let's call it triangle BCA. So if I called that triangle BCA, what am I going to have to call this triangle? If I call this BCA, no, watch. EFD, right, EFD. All right, and I have to call it that. That's my only option. Okay? You understand that, right? Okay, this is the only option. If I call this BCA, do I have to call this BCA? No, I don't have to call this BCA. But if I call this BCA, I absolutely have to call this one EFD. Right, I have to call it. They got to match up. So how can you always check? Well, the B and the E, are they in the same spot? Yes. Is the C and the F in the same spot? The C and the F, yep. Is the A and the D in the same spot? Yep, they are. All right, so as long as they match up, as long as they correspond, that's perfectly fine. I can call it that. You're going to have some problems on quizzes and tests and on the homework where you're going to have to write a congruent statement. Yeah. Yep, okay. It's going to be something like this. It won't be exactly this. It'll be something very, very similar to this. I'm going to say, listen, I'm going to say, write a, what does it say? There's two parts to it. I think it just says, write the congruent triangles. Okay, so you would write this. There's something else to it. I forget. Anyway, but you're going to have to write two things, and I forget what the other one was. Okay, but one of them is write a congruent statement. Okay, we'll get to it in the next lesson, I'm sure. All right, so that's the kind of stuff we're going to do. Let me show you one more thing, and then we'll be done. All right, let's do this first one right here. This is ABC. I want to show you something else. Let's do this in a different color. Watch this. Do you see this line segment AB? See that one right there? Now, looking at the picture, I could see which one is congruent to line segment AB. What's congruent to line segment AB over here? DE, right. If I go AB, then it's what? DE. You with me? So check out the congruent statement. Look at the AB. What does it match up with? The first two match up with the first two, DE. That works, doesn't it? Okay, let's do this one. What about BC? This is BC. It should be EF. Does it match up to the second one and the third one? Are the same thing? Yep. And what's the other one? AC, right? AC matches up with what? DF. See how it works on the congruent statement? If you got them mixed up, there's no way you'd be able to tell what angles are equal to each other and what sides are equal to each other. But I can not even see this picture, and if I see this congruent statement, I know that AB and DE, or AC and DF are equal to each other. I know that AB and DE are equal to each other. I know that BC and EF are equal to each other just by looking at the congruent statement. You see the difference? You see why it's important? And it works here too. Look, okay, AC and CA, it's the same thing, isn't it? AC is the same as DF or FD. You see that? So those two line segments are going to equal each other. So if I gave you something like that, watch. If I said triangle, I don't know, QPR was congruent to triangle LMN. Tell me which angles are equal to each other without even looking at the triangles. Q and L are equal. Angles P and M are equal. And angle QR and N are equal. Which line segments are equal to each other? QP and LM. What else? PR and MN. And what else? QR and LN. Okay? Just by looking at this congruent statement, I can tell you which angles are equal to each other on those two triangles and which line segments are equal to each other on those two triangles. You see how important it is to have the correct congruent statement? That's why I'm going to mark it wrong. Okay, if you don't put them in the right order, that's why it's going to be wrong. All right, because it's so important that you have them in the right order. It's really, really important. Make sense? Okay. That's only half of that lesson. I got a little bit more to teach. We'll do that tomorrow. So don't worry about homework on 4.2, but you do need to do 4.1. I already wrote this down earlier, didn't I? 4.1a and 4.1b. All right, so those are due tomorrow. 4.1a and 4.1b. Make sure you have those done for tomorrow.